Good morning, folks. All right, say hello and I can check in here in our snowy February. See who we got out there. It's Lee. Morning, Lee. Hope you're well, staying warm. And Julian. Hey, Julian. There's Ali. Hello, Ali. Glad to see everybody, so to speak. Nicholas and Isabella. Super. That's a good start. Okay, who else I got? Tadashi. Hello. Welcome to chemistry, everybody. Physics is Schnee van gestern. Oh, come on, let's get a few more. There's somebody. We'll get 10, 15, then we'll start up for the day. We're going to review naming alkanes and everything we need to know to start 10th grade chemistry. There's Larissa and Tom. All right. Nicholas, I sent you guys a link. And I think you can join the chem classroom with that. Has anybody done that successfully? Have some of you already used the little code? It's in the link to join the chem classroom. Are any of you in there yet? Because we'll stop using the physics one once I get most of you here. Tom says yes. So that link is in the stream for the 9 or the 10 physics yet. Okay. Good. And we got Lily here and Vincent. Super. We're getting near what I'd call a critical mass, and we'll start up in just a moment. Let's get one or two more. There's another one. I got Julian K. All right. Are we going back next week? I wish I knew, Ollie. The big wigs are going to decide, I think, Wednesday, tomorrow, and then we'll see what the deal is. But I know as little as you, Ollie. Okay, Julian K. is here. Dynamite. Noah is here. Welcome, Noah. Sarah is here but can't comment. Thank you, Lily. Then we will mark Sarah as here. Good morning, Sarah. And Natalie, gotcha. Natalie, gotcha. Super. Everybody's flying in. Okay. Do I have Magdalena out there, or Priya, or Aiden, or Shilpa, Lena Deacon Riley, or Christian, or Dominic, or Merla? If any of you are out there, say hello. Other than that, I'm going to go ahead and start up because everybody got up early, and I want to thank you and go ahead and begin with you. So, I know it's new stuff, but we need to review naming alkanes first. Remember that with last year? Naming alkanes. So all those same word prefixes, so to speak, or same words, those the basis of organic molecules, You got to know those words for this year too. So I'm going to write them up here. You guys tell me what they are. You ready? Here we go. CH4. Here, I'll just put number 1. C2H6. C3H8. By the way, this is the number of carbons. 1 carbon, 2, 3, 4. And if you haven't had this before, I don't know if Lily's had this or not. Okay, Sarah can comment now. Oh, and I got a couple others. Hold on, let me quickly put them in there. I've got Magdalena and Deacon. Deacon, Magdalena. Good, good, good. All right. Okay, C4H10. C5H12. C6H14. C7H16. Yes, we're almost done. 8, 9, 10. C8H18. C9H20. C10H22. Okay, why have I done this? Because I want you to give me the names. So folks that have had this before, any that you remember, just write a number, like I know number 4 is blah, blah, or whatever, okay? And give me the names, because we need those root words. There's the English word. We always going to have live stream on Tuesday morning. Due to schedule change, we now have music Tuesday, first period. Really? I wish they'd send me a new schedule. I didn't know that. Okay, so the short answer, Magdalene, is no. If, God, that kind of ticks me off. Okay, well, I'll come back to that, Magdalena. I can't answer that now. Okay, so here we go. I got some from no. Okay, give me a number and tell me what it is. Don't just give me the names. Like, I don't know if octane's like for 10 or 3 or whatever. So give me a number and then tell me what the heck it is. Okay? Don't just spit out some names. Because I got to make sure you know what name is what number. That's my point. That's why I numbered them. Thank you. Okay, Ollie's got one. So this sucker is methane. So we need the meth, so to speak. Good. 7, Nicholas has is heptane. So hept is the prefix we need. The ANE is just telling it's all single bonds. There's a bunch more. They're flying in. And I've got octane from a couple of you, including Vincent. So like an octagon, octane. It's all coming back, right? I hope so. And I got 2 from Sarah and Lee, which is F. We need that a lot. Ethane. I got 3 from somebody. I do. Magdalena has 3. That's propane. So 4 from somebody. Yeah, I got 4 from Magdalena and Sarah. And they know that that one's butane. That one a lot of people forget. It's in your lighters if you have a lighter for lighting up your bonfire. And 5 we got from a couple of you. Let's see if anybody else knows 5. Ooh, I only got 1 5. More of you should know 5 from math class. 6 we got from a couple of you. Tom has 6. That's hexane. Like a hexagon. And yeah, okay. And 5 we got from Sarah, and I think she's the only one. So it's pentane, like a pentagon, right? For all those witches. Penta. Good. I need 9 and 10. Do I got 9 and 10? I do. From Nicholas, he's got 10, which is decade, like a decade. Whoa, that's way down in the board. And then 9 is no name. Thank you, Tom. You ever hear that old song? Been through a desert on a horse with no name? I know, way too old for you guys. Sorry. Okay, so to put it short, including those that haven't had this before, you need to know these prefixes, okay? Because we're going to use them in new chemicals, but they'll have the same start, okay? Including alcohols and acids and esters. Alcohols, acids, and esters. And maybe ketones if we do those, or ethers. Anyway, let's go on. Anybody else new out there that I haven't gotten yet? I still need one last check for names. I still need Priya and Aiden and Shilpa, Lena, Riley, Christian, Dominic, and Merla. If any of you are out there, please say hello. Okay, so next I want to take one of these. Let's just take a pentane and put a branch on it and see if you guys remember how to name that. So there's the basic structure. I'll put some hydrogens around it. And ask you how to name that. Oh, Marila's here. Okay. So I want the name of this thing. First, the main chain, maybe, and then this thing, and how to write that from last year. Okay, type in your guess for the name for this sucker here. Do we remember? Ooh, how long it's been. Close, Tom. I agree with the pentane part. The long chain is pentane. Yeah, exactly. So which is it? Let's see if somebody else jumps in here with a guess as well. So Tom's got two answers. One of them is correct. Okay, good. So remember, we number our carbons. So this is 1, 2, 3, 4, 5. And the branch is off a 2. And it's a methyl branch. It's a branch of 1. So I go dash and methyl. Remember, the YL tells you it's a branch. Huge. Let's do one more. You guys seem a little rusty. Okay, so oh, let's just do it here. Okay, so let's get the name for this sucker. At least give me the main chain name. Everybody should be able to do that. Erase that. Write the name up here. How about I call somebody? Lee, what's the main chain name? How about Lee? Lee was the first one here this morning. He must have had some tea or coffee already. Wow, he's got the whole name. Yeah, so heptane. That's right, Lee. Okay, the rest of it we're going to help you out on. I don't think the whole thing is quite right, but we got heptane. Yeah. So heptane is right. 1, 2, 3, 4, 5, 6, 7. That's his longest chain, remember? Okay, now we got to talk about branches. Let's check them out. There's a branch. There's another branch. And here's another one. No, they're not connected, everybody. They're separate branches. Remember, these can move like fingers. Okay, these two branches, they're not connected to each other. Okay, so tell me about the branches, somebody else. Now, this is not an ethyl branch, gang. This is two methyl branches. So altogether, I got 3 methyl branches on this thing. So how do I write that? Yes, I know it's been a while. Sarah's on the way. Yeah, methyl. I need methyl. And I need a prefix from Sarah as well, and Larissa. I need a prefix. How many methyl branches do I have? What's the prefix in front of methyl? I'll put it in another color just for grins. Methyl. See who remembers that? Methyl heptane. Yeah, good. Magdalena's got it. Yep. And in a sense, I got to say try. So Isabella, instead of 3, we write try for that. Okay, now let's put the locations. I got one at 2. I got one at 3. I got another one at 3. Dash if you want it. So 2, 3, 3, trimethylheptane. All right. Let's do a line drawing for this as well. By the way, if you haven't had this before, if it was 2 branches, that would be the prefix di. So di equals 2 branches. 1, you could say mono, but nobody does. And then 4 is tetra. Okay, so you got di, tri, tetra. That's really enough. Okay, we don't really have a lot of 5 branches on things very often. Okay, because carbons can't hold it. Righto, righto. Let's do a line drawing for this. We did this last year, but only one day. Okay, for a line drawing, we go like this. We got 1, 2, 3, 4, 5, 6, 7. So I go like this. 1, 2, 3, 4, 5, 6. Now, that is supposed to represent the main chain. Let's see if it really does. I should have a C at each little like corner and each end. So I got 1, 2, 3, 4, 5, 6, 7 C's. Yeah, so that's right. And then I got some branches, so I can do a CH3 here. Let me think of how I did that last year. So on the second one, I got a CH3. And then on the next one, I got 1 going up and 1 going down. I think that's all we got to do. And that is a line drawing for that thing. Okay? Did we do that last year? I hope so. I hope so. The last thing I want to do with you is, oh hell, okay, is a condensed formula. So here's a condensed formula. And it goes like this. I'm sorry I erased this. I didn't mean to. Pardon me. Let's repair it. Okay, for the condensed formula, we got to walk across it. Oh, Lena's here. Okay. Yeah, you'll have to watch the rest of it, Lena. Okay, so for a condensed formula, you got to walk across the thing and see what you got. So let's have a look. So I got a CH3. So I write that. And then I got a CH. You notice that? That C only has one H on it. And then I got a branch on that. And I can put the branch to make it a branch in parentheses. So I can say CH3. And then I got a C, just one C. And I know that's got to have branches, so I can put that in parentheses like this. CH3. And I can put a 2 down here. Why? Because I got two branches, one above, one below. Okay, then I got another C, and this has two H's on it. So I got CH2. And I got another CH2. And I got another CH2. And I got a CH3 at the end. That's almost done. Now, the other thing you can do here, gang, is you can combine these also. I know it's a little confusing because it's hard to know what's a branch and what's not, except that if I got a CH, I know I got a branch. And if I got a C, I know I got two branches. That's how you know these are branches afterwards. But I can combine these like this. See those three? Excuse me. I got three CH3s. So really, this would be like this. It'd be CH3, CH, and then off of that, I got a CH3 branch. And then I got a C, and then I got two branches off that, and they're both CH3s. So a 2 to show I got two branches. Then I got 1, 2, 3 of these. So here's how I do that. Another set of parentheses, CH2, and how many of those? I got 3 of them. And then at the end of the molecule, I got a CH3. Now that's a little harder, isn't it? Because you really got to think if it's a branch or not. The branches, notice the branches come after these C's that are missing some H's. So that's not a CH2. That's got a branch, boom. That's got two branches, boom. There they are. This is not anything except just in the main line, 3 more CH2s and then a CH3 at the end. Okay? Yeah, I know, kind of crazy. But you'll see some of this throughout the year, so I want you to remember vaguely what that was about. Okay? So that today's kind of a review day for that. Okay, let's try a couple more names. Ready? Ask me if you got questions. Yeah? There's one already. Good question from Noah. He says, we got CH3s, we got 2 of those. Can we combine them? No, you cannot, Noah, because they're not next to each other. So they got to be next to each other to combine them. There's one at one end, one at the other end, and then there's some branches. So no, you can't combine those. There's still, you have to be shown the shape with the formula. So no can do. Okay, let's name a couple others. Let's do the opposite. Let's give you a name and think about drawing it. Okay, so 4,4 dipropyl octane. 4,4 dipropyl octane. Okay, so go to the main chain first. Octane. How many do I got in the main chain? Yes, I know you should all know. How many in the main chain to draw this structural formula? Thank you. Everybody's jumping in. Sarah, Marilla, Lee, Tom, good. So they say 8. So I'm going to draw 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. And then it says I got dipropyl. Well, what the heck's a propyl? It's a branch, and how many is in a propyl branch? How many is in a propyl branch? What would be appropriate for a propyl? Or is it a propylum? How many in a propyl branch? What does prop mean? Thank you. Good. Got a lot of you already know that. Thank you, Lee, Tadashi. So it's 3. Now let's see where they got 2 of them. Dipropyl, 2 branches. And they're at 4 and 4. Well, let's draw the first one. 1, 2, 3, 4. So there's 3 coming off the bottom. 1, 2, 3. And 3 going off the top. Oh, man. How am I going to do that? I didn't make enough room. We'll just make some room. So 1, 2, 3. And now fill it with hydrogens. Everybody needs hydrogens, so the C's have 4 bonds when they're done bonding. Good. There you go. Okay. Questions there? We okay? I'm going to come and make some space over here while you think about that. I hope this is bringing back happy memories from drawing organics in the spring. I think with me. Let's do alkenes and alkynes. Okay, alkenes have what? Alkynes have what? So why alkenes, why alkynes? Magdalena asked, when you use hyphens or blanks? I use hyphens often between the branch ending and the name. But if I forget, it's probably not a big deal. Like blah blah propyl dipropyl octane. And Magdalena, in German, they just shove it all together, okay? So in German, it would be dipropyloctane, dipropyloctane, propyloctane. So if you have it in German next year, don't worry. It's all just the same. You just forget anything and just shove it together, okay? Good, double bonds. Thank you, Lee. You're right. So alkenes have at least one double bond. And so everybody, alkynes probably get at least one triple bond, right? Singles, doubles, and triples. Let's do one because we're going to have some double, maybe triple, but at least double bonds during 10th grade chemistry. So remind you how to do that. You still doing okay? Yeah, we're going to do okay. See if you got any questions. Exactly. Deacon had the triple bonds. Thank you, Deacon. Is that always? Yeah, Sarah, for the most part, it is always the jamming together thing, if that's what you mean. Okay, so let's do an alkane. So we're going to do boom, shaboom, 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 shaboom. Okay, now fill in with H's, don't forget that. So we'll do bum, 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 bum. Okay, how about Lena? Lena, are you out there? Could you give me the main chain name? What name will this be? Bum, 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 bum. See if Lena can help me out. What's the main chain name? Just because I haven't talked to her yet. Who else could I call on here? Oh, yeah. Yeah, let's call on her. Okay, so how about a main chain name from Lena? I'll change markers while you're thinking here. Okay, then how about Merla? Main chain name? Butane, you got it. So bute means 4. Thank you, Merla. So I got bute. And now I got a different ending, somebody else. What's the ending if it's got a double bond in there? It's no longer butane. Hint, it's an alkene now. So somebody else punch it in. Appreciate your participation here in my basement. Thank you very much. Thank you, Tom. Thank you, Magdalena. Good. So it is indeed butene. And now what we can do is we can say where that double bond is. So if you haven't done this before, the double bonds are the bonds are numbered. So that's bond number 1, 2, 3. So this is the bond is at 1. So it's 1 butene. Ta-da! 1 and we're done. So that's good. I can put branches on it as well and make it more complicated, but that's how you deal with the ENE. Double bond where? First bond. First bond. Right there it is. Boom. That sucker right there. That first bond is my double bond. Okay? Alkynes work the same way, don't they? Good. Ask me questions if you're unsure of something, okay? I'm going to make a little board space while you're thinking. By the way, if you want to do a line drawing of this one, it would be like this. Because there I got 1, 2, 3, 4. And to show the double bond, you just go like this. You add another line next to this guy. Ready? Like that. Okay? And then you're done. That's the line structure. That's the line drawing for this one. Okay? So pretty easy. And then for the condensed formula, let's just do that to review. It's a CH2. And then we draw a double bond. And it's weird because it looks like it's between the H's. It's not. Okay. And then we draw a CH. And then we keep walking, and now it's a CH2. And we keep walking to the end. Now it's a CH3. Okie dokie. So for a double bond, you put it in the condensed formula, like so. Hunky dory? We okay? See if we got any questions. We do. Okay. What symbolizes the double bond in this scenario? The dash after the 1 or the suffix "-ine"? Good question. So the double bond, it's because I got this. So this, Lily, means double bond. And this is the location of that double bond. So it's bond number 1. But the E&E tells you it's a double bond. Good. Any other questions? Yeah, Sarah's answering there as well. Thank you, Sarah. Good. Appreciate that, everybody. Let me blow my nose. I'm sorry. Got the sniffles. Don't worry, it's not corona. Just got the sniffles. I haven't been around anybody but the cat. Okay, so here we go. Let's continue. What else do you need to know? Well, you need to know this. I think we had this last year. Does that ring a bell? Okay. Did we have this last year? What the heck is that? No, it's not something from physics. It's 6 C's with essentially bonds like this. But it really doesn't look like that. It looks more like this. Yeah, thank you, Tom. You got it. It's a benzene ring. And the formula is C6H6. And we'll need this year for some reactions, so I'm reminding you what it is, okay? So it's like you can imagine that it's got a double bond on every other one, but it doesn't. Instead, it has a rotating ring of electrons. So think of electrons in the middle, and the electrons rotate from bond to bond. So, and so all the bonds are really the same between the carbons. And to show that, they show this sort of structure. So that means a rotating ring of electrons and 6 C's, 1 at each corner, and on each corner is also an H. Okay? So that's a benzene ring. And we'll need that for this year as well for some compounds we build. Is it coming back? Yeah, exactly, Sarah. Okay. Beautiful. Let's see what else we need. This is my wake up and smell the alkanes morning, right? Although they don't smell very good, because we gotta have them ready for this year. Okay, we need the word isomer. What was an isomer from last year? Oh, and I got a question too. Okay, Magdalena asked if there are quadruple bonds. You know they're not, and here's why. If I try to have a quadruple bond, what ends up happening between a C and a C is there's so many electrons. There's 8 electrons then. Remember, each bond is 2 electrons. There's just too many electrons, Magdalena, and they fly apart. There's too much repulsion. So the most I get is a triple bond, and even that's pretty rare in chemistry. Double bonds are much more common, and we'll have a lot of those this year. Okay? Triple bonds occasionally, never a quadruple. Too many electrons, it's just unstable. Good question, though. Okay, what's an isomer, gang? I'll start you out. It's the same blah, 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 but different. Blah, blah, blah. See if somebody knows. Okay, Sarah says it's the same molecular formula. She's right. Like C6H6, for example, would be a molecular formula. Good, but a different blah, blah, blah. A different, oh, you are on your game, Sarah. Good. Different structural formula. So let's draw a couple of isomers. So example. I know the ages take a while. That's life. Life here in the chemistry lane. Okay, so what I got here is what? I got 3 isomers. For C what? 5. H better be 12. Remember that trick, everybody? We double the first number of C's and then add 2 to get the number of H's if it's an alkane. So this one is just straight pentane, isn't it? And we separate them. So there's pentane, there's 1. 2 has a branch, and I just put it I put it on this carbon just for the heck of it, and then 3 is this guy here. So there's 3 isomers. There might be more. I don't really care. I just wanted to remind you that these are different structural formulas, but they all have the same molecular formula, C5H12. Let's name those for grins, okay? So the names, 1, 2, 3. If you can name one, please do. So give me whichever one you're naming, 1, 2, or 3, and then tell me what you think is the name. Is that hard to see? Can we see that? Is it in the glare? There you go. Is that a little better? So tell me 1, 2, or 3 if you got a guess, and then what is the name of each of those, okay? 1, Magdalena's nailed it. It is pentane. And we can call this N-pentane. N means normal. Boring inaligned pentane. So N for normal. Yeah, so first one is just pentane or N-pentane. Let's see if we get 2 or 3. Good, a lot of you had pentane. So Noah had as well. And, ooh, Noah's got one for the other one. And, yeah, and so does, okay, good. All right, so, yeah, good. Ooh, you guys are good. Isabella, you nailed it. It's 2. The branch is on 2. So it's butane. Let me write that down. So everybody, it's a chain of 4. That's the main chain. Now what you got to do, which Isabella remembered, is I got to go to make it the shortest direction. So if I got this side, it's 3, but really if I go this side, it's 2. So we're going to call it 2. And then we got to have a name, though, in there for the prefix. So 2, what would be the prefix? Hint, there's my branch. 2, butane. So what fills in the blank here? 2, butane. And you guys are thinking, and we're going to come back to Noah for the next one. What's in here? Thank you, Isabella. 2-methyl, right. Good, 2-methyl butane in there. Good. And the third one, okay, so for Noah, he says it's propane. So that's 3 C's. I agree. And then he's got 2, 2 for the locations of the branches. One's at 2 and the other one's at 2, and they're both methyl branches. But it's a little repetitive, Noah. We got to have something before the methyl. Methyl. 2, 2, methyl propane. Right, I run out of room. I'm just going to put it in here. See if somebody knows. Yeah, Larissa's got it. So 2, 2 dimethyl. So di, it's a little weird, but I got to have di to show I got 2 branches. Sorry, it's what they require. What kind of branches? Methyl branches. So 2 methyl branches, where are they? They're at 2 and 2. And here's the one we're doing, just a reminder, the one Noah started us off at, 2 and 2 on a propane stem, or parent chain, you can call it propane, the parent chain. Okie dokie? Life pretty good? Life's pretty good. We're done. Sorry, I took a minute extra of your time. So I may give you something to review on, but thanks for coming, everybody. I'll send that to those who were either sleeping or had something else. And I'll check your schedules. If you really are like in a different hour, then they better tell me that. Doggone it. Okay, thanks, everybody. Have a good rest of your day. Stay healthy. Bye-bye.